Hello guys and welcome back to this amazing channel. This is Abhinav. Today in this particular video we'll discuss the problems of Codeforces. It's educational Codeforces around 169. I actually love this educational Codeforces round a lot because in every educational Codeforces round you will learn something new. Yeah, that is why they are named as educational, right? Amazing. Okay, in this particular video, we'll discuss about the first 5 problems of educational Codeforces round, which is from A to problem number E. Okay, this is what we will discuss in this particular video. And yeah, we are again back with our Codeforces solutions from the last some months. Actually, I was not very active because of multiple other activities through which I was going on. But yeah, now I'm again back on YouTube with all the contest of lead code, code step, and Codeforces for you guys, right? Amazing. Okay, so let's start then. Let's start with the problems. I will say this contest was, not that much easy, not that much difficult. The first 3 problems was of, were of basic level only. I will say even the second B problem was even more difficult from the problem number C. What I actually feel from my side, because a B, it was not actually much difficult to think of, but to implement it was really on a higher level. Most of you I think have faced difficulty in this. And then yeah, C was a very basic problem, I will say. D was also a good problem but a complex one, and obviously E was a little more complex problem. Okay, so yeah, this is what all this problem is actually, right? So let's discuss all the problems one by one. So the very first thing is A, which is closest point. So the problem says that you have to consider a point on a line such that the distance between 2 points I and J is I minus J. Means basically the distance between every 2 point on that line is basically the distance between their values, right? Means the absolute difference of I minus J. Now, now they are saying is that a point I is closest to point J such that there is no other point which is having a less distance than I. Basically, 2 points are closest on the basis of their distance. That is what they're trying to say, right? Now, what you have to say is you have to tell that whether it is possible to add a new integer point within that set of points so that that new integer point is closest to all the other points. That is what they are asking, that new point should be closest to all the other points if it is possible in any way. Okay, that is what you have to tell. Up, see guys, the basic thing that here you have to see is that, let's say, so, and also they are saying that the number of points will are always more than equal to 2. Okay, now let me give you an example. For example, the number line that is given to you is like this. Let's say this is the number line. Okay, so this is 0. Okay, sorry, yeah, this is 0, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and our n is always greater than or equal to 2. Okay, let's say that we have these 3 points, P1, P2, P3, and P4. Okay, if you will see, for P1, P2 is closest. For P2, P1 is closest. For P3, if you will see, both P2 and P4 are at the closest. For P4, P3 is closest, right? So for every point, there is some closest point to each. Can you tell me, can we put any extra point on this number line such that that new point is close to all the other point? Is it possible? Okay, tell me. Guys, it is not possible. See, if you will place that point anywhere the number line, let's say you place that new point here. This is the new point. So it is closest to P1 and P2, but it is not closest to P3 and P4. If you will place it here, it will be closest to P2 but not to anything else, right? So basically guys, whenever the value of n is greater than 2, then this thing is never possible. It is never possible. The new point is only possible when there are only 2 points, when the value of n is 2. For example, if the value of n is 2, then only it is possible. And then also there is a condition. First thing is that there should be only 2 points, because if there are only 2 points in the number line, then what we can do, we can place that third point in the middle of those both the 2 points, in the middle of them. If I will put them in the middle of, that means we can get it closest to both the point. But अगर एक भी मान लो मैंने उसको मिडिल में रख दिया एंड पॉइंट को, अब यहाँ पे एक भी और P1 P2 होगा ना, if there is any other P1 P2, for that middle point or that new point will not be closest. So the first observation is that the number of points should be just 2. And not just 2. The second thing is that there should be some middle of that point. For example, if you will see current P2 and P3, there is no middle point. Yeah, there is no middle point because there are only 2 points between it. So if you will try to put this and here, then it will be closest to this. Okay, wait. Yeah, sorry. Here it will be possible. Sorry, here it will be possible. Why? Because if you will put it here, then it will be closest to it, or it will be closer to here, it will be closest to it. But the thing is, there should be at least one point in the middle now. Let's say if P2 and P3 are like this, just adjacent to each other, then it is not possible because then there is no point in between it. If you will put your n here, it's not a true case. If you will put your n here, it's again not a right case. So two conditions are there, that there should be only 2 points. For more than 2 points, answer is always no. And if there are 2 points, then those 2 points should not be adjacent. Means difference between those 2 points should be more than 1. Right, here it is just 1. So you can see my summation also. I did the same. So what I did is, first of all, if number of n is greater than 2, pn means print no. And if the difference between those 2 points, if there are only 2 points, let's say, but if the difference is also just 1, difference in the position, I mean, then also pn means print no, otherwise print yes. Okay, this is what I'm doing. This is how we are solving this third problem called closest point. This is how I will say a basic problem, not a difficult problem, just the observation based problem it is, right? So I hope that you've got the understanding of this particular problem. Let's move to the next problem. Okay, amazing. So I have to actually check that OBS in between, because nowadays I'm not sure my this laptop is having some problem with this OBS. I have to actually uninstall it and install again. There is some problem with my OBS. I have actually installed a lot of extensions and all, because of recording. But yeah, I'm not getting time to uninstall OBS and again installing it and configuring it for my YouTube. So yeah, that is why it hangs a lot nowadays. I will check it. What's the problem? That is why in between I used to check whether it is running or not, or whether it is stopped, right? So yeah, this happens actually. No worries. I think we can move forward to next problem. So his next problem is this game with doors. It is actually a very good problem. What does this problem say? This problem says that there is Alice who is basically present in between somewhere from room number L to room number R, and there is a Bob who is somewhere between the segment capital L to capital. Okay, and that is a guarantee that they both will be in a different room. This is a guarantee. Okay, now what you can do, so if all these rooms are actually connected with each other with some door. So for example, it is like this. Let's say there are some n rooms, for example. So they have I think said it as 100 rooms, but for example like this. So let's say these are some rooms. Zero, okay, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, तो यहाँ पे हम लोग 12 रूम ले रहे हैं. It is up to 100 rooms are there. Okay, and what is happening that they are saying कि okay भाई हमारा जो I think Alice and Bob ना वही होते, तो हमारा Alice है, he is between room L to R, anywhere in between in a single room L to R, and Bob is in between capital L to capital. Okay, by the way, in my code, I think in my implementation, I've taken this as A, B, and X, Y. Okay, so you can take it like that only, how we have taken in the code. So Alice is between A to B and Bob is between X to Y. Okay, this is what we have taken. Now understand very carefully. Currently, what is happening is that between every two rooms, these all are rooms, right? So between every two rooms, there is a door. These are doors. Basically, from one room, you can go to the second room. And this is how you can move to any other room from one room. From each room, you can go to any of its adjacent room because there's a door in between that, right? But what you can do, you can also block a door of some rooms. For example, if I will block these two doors, that means this cannot go here, and this from here the person cannot go here. Means the path between the third and fourth room is blocked, and second here the path is blocked. So basically, whenever I will close a door, that means that particular path between that both room is locked. person cannot go through that, right? What they are saying is that Alice is present in between some room from A to B. Let's say A is 2, B is 5. तो मतलब जो Alice है वो इस A से लेके B के बीच में होगा, for example. And Bob is somewhere between X to Y. Let's say X to Y is this. Let's say, just I am telling you a example. We will check all the test cases, right? X to Y. ठीक है. अब इस केस में you have to find that कि how many minimum number of doors you have to close such that Alice and Bob can never meet. Such that Alice and Bob can never meet, right? अब देखो guys, यहाँ पर the thing is that we have to check all the possible cases, but how in a better way. So you can see this is a code I've written, which where I have actually added a very good logic. So what I'm basically doing is, see, understand one thing very carefully. There will be different cases, right? There will be different cases, and for every case my this code will work. How? Let me tell you. तो मैं क्या कर रहा हूँ, मैं सबसे पहले आई एम फाइंडिंग द मैक्स ऑफ a comma x and min of a comma x, then max of b comma y and min of b comma y. Okay, this I am basically doing to just see if which is the max of a comma x. मतलब ये जो स्टार्टिंग पॉइंट ऑफ एलाइस और बॉब है, इसमें मैक्सिमम स्टार्टिंग पॉइंट क्या है. फॉर एग्जांपल इन दिस केस इट इज ऑफ बॉब, एंड min means which is the first starting point, and again max of b comma y means the second ending point, and min means the second ending point of this. Okay, it can be anything. आप समझना एक बात, ठीक है? Understand one thing very carefully. There will be 5 different cases, or I think 4 different cases. Let's see all the cases one by one. पहला केस क्या होगा? The very first case will be when the range of Alice is separate and range of Bob is also separate. They are not intersecting. That is the first case. First case क्या है? First case है कि जो range of Bob है and range of Alice, both the range are separate. They are not intersecting. They are not intersecting. So when they are not intersecting, that means we only require one door to be blocked. Our answer will be one only. How? Because if they are not intersecting, Alice is somewhere in between this, Bob is somewhere in between this. So I have to just close one door, any one door. It can be either this one, or this one, any of them. Got it or not? Right? यही होगा ना. अब ये पता है कैसे लगाओगे whether they are intersecting or not. So if you will see in this particular case, in this case I will say a is 2, b is 5, x is 8 and y is 9. So you will see that max of a and x is 8, min will be 2, max of b and y is 9, min is 5. ठीक है, तो मैंने अभी क्या किया, मैंने यहाँ पे l माना है max of a comma x को. So I am saying this is l and min of b comma y is r. Why? Because you will see this 5 and 8 ये actually में क्या है, ये they are the ending node here कि which is the minimum value where this end nodes are ending, कि कहाँ तक minimum जा रहा है. तो देखो बेसिकली निकालना क्या है, we should have doors at the point जहां पर Alice and Bob intersect कर रहे हैं. तो where Alice and Bob are intersecting ना, in all that rooms we have to lock the door so that they cannot meet. But in this case you can see they are never intersecting. And how we will define this thing? So if the min of y जो कि ये है और max of s, min of the second r I will say and min of l, if they are apart, मतलब अगर ये r l से छोटा है, which will only be in the case when they are not intersecting. So if they are not intersecting, through this case you can see my answer will always be 1. मेरा आंसर हमेशा 1 होगा because they are not intersecting. अब देखो, so I'm saying when AB is a separate segment, XY is a separate segment, they are not intersecting. That means answer will always be what? It will be just 1. Up one case will come when they are just intersecting in one room. I think that case can be already considered here, but I have taken it here. I'm not sure. I've taken it separately. Maybe it cannot be covered here. Okay. अब ये केस क्या होगा, ये वाला समझना बात को कि Alice ऐसे है, बॉब ऐसे है, या बॉब एलाइस ऐसे, कैसा भी, इस तरीके से। फॉर एग्जाम्पल कि एलाइस इज स्टार्टिंग फ्रॉम 1 to 5 and Bob is also starting from 5 to somewhere at 7. In this case, you can see that in this case, if you will find the value of L, what is L? L is max of a comma x, कि भाई maximum कहां से start हो रहा है, तो यहां से हो रहा है। max of a comma x is 5 and min of b comma y is also 5, means जहां पे पहला वाला end हो रहा है, where the first is ending, which is max of a comma x, oh sorry, b comma y, min of b comma y means कि जो फर्स्ट सेगमेंट है जहां पे एंड हो रहा है, min of b comma y means the first segment where it is ending, वो, and the second segment where it is starting, they all are both, they are all same. So if they both are same, in this case you need to block two doors. What two doors? First is this, second is this. Why? Because your allies can be here, Bob can be here, or your allies can be here, Bob can be here. मतलब allies यहाँ से यहाँ तक कहीं भी हो सकता है, Bob यहाँ से यहाँ तक कहीं भी हो सकता है. Obviously they will not be in the same room. So we have to block every that room which is coming in the intersection. जहां पे intersect कर रहा है वहां पे होना चाहिए. अब let's intersect more. अब for example the intersection is like this. Let's say the intersection is like this. Okay. For example, let's say Bob is first. So let's say यहाँ से यहाँ तक Bob है. So X is 1 from room number 1 to room number 6. And let's say Alice is here from room number 4 to room number 8. अब इस केस में आप देखो तो you have to block these doors, 4 doors. So first of all we have to see कि which are these intersecting coordinates, कि कितना कॉमन है, कितना इंटरसेक्ट कर रहा है. And to find this intersection, as I told you, it will be nothing but the maximum of a comma x, which is 4, and the minimum of ये y है, हाँ, and the minimum of y comma b, which is 6. तो आप देखो 4 से लेकर 6 तक वाला जो है हाँ वो आपका इंटरसेक्ट कर रहा है. 4, 5, 6 ये जो रूम है इंटरसेक्ट कर रहे हैं. And how many doors are present in between these rooms? Not corner. तब देखो 4 से 6 के बीच में दो डोर हैं, तो वो डोर में ब्लॉक करने ही पड़ेंगे. We have to block those 2 doors. So if you will see, what was our L was max of a comma x, R was min of y comma b, which is actually the coordinates of the intersecting rooms. कि ये rooms intersect करें. Intersect means in these rooms both Alice and Bob can be present, right? So that R minus L will always be an answer, because these doors should always be blocked. They should always be blocked in between. But in some cases they can also be blocked. No, not in all the cases. ये क्यों ब्लॉक, ये इसलिए ब्लॉक हो सकता है बिकॉज यहाँ पे एलाइज हो सकता है, एंड इफ एलाइज इज हियर इट शुड नॉट गो हियर बिकॉज बॉब कैन बी हियर, बट विल ओनली बी देयर बिकॉज यहाँ तक एलाइज की रेंज है या फिर यहाँ तक बॉब की रेंज है. If Bob and Alice's range is not after this room, that means it is not required. So if you will see, what I'm doing is I'm checking. If the min of AX is less than max of AX, then only increase the answer. Matlab, because you can see here, the minimum of A comma X is 1. That means Bob or Alice, whoever, is having a more range on the left side of this common door. So these are the common doors. These are the common rooms, sorry. These are common rooms where both Alice and Bob can be there. But now you have to see कि क्या इसके पहले भी कोई रह सकते हैं? Yes. Before this also someone can live. It can be either Bob or either Alice. Doesn't matter. But someone can live here. That means there is a risk such that कि ये इससे मिल जाए आके. That means you have to block this door also. And if after this also someone can also live, means if min of b comma y is also min of b comma max of b comma y, then also will door ये वाला. So basically the thing is that we know कि ये दोनों डॉट तो ब्लॉक होंगे ही होंगे. Doors between L, so this is L, this is R, so we know between L and R, between those rooms ये दोनों डोर तो लॉक होंगे ही होंगे, which is the difference of L, R and L. But these corner doors should also be locked, can also be locked, because we know this is a common rooms where both Alice and Bob can live. So in between door will be locked. This will be also locked if there's a scope of someone after it also. You can scope है यहाँ पर. हाँ, अगर ये ना होता यहाँ तक B. Let's say B is not till here. B is also only till 6. Then this door lock was not required. It was not required. Why? Because there is no one after it, na. There is no one after it. So even Bob is here, there is no one after it. Everyone will be this side on. So there is no need to block this door. And how we will check this? So you can see now, you can see here X and B both are same. So if X and B both are same, that means the value of max of, okay, this is Y. This is not actually X. This is Y. X to Y. So Y and B both are same. So we can do in this way also. Instead of this, we can simply check if B and Y are same or if A and X are same. ये भी कर सकते हैं कि if B and Y are same or if A and X are same, then don't remove it. And if they are not equal, then only increase. Okay? तो यहाँ पे ऐसे increase नहीं होगा. But here it is increase. Okay? So this is how I actually solved this problem, guys. With the B problem, I understand it is actually a problem, a complex one. And this is how we have solved it. So I hope that you have got the understanding of this particular problem. If still you have any doubt, you can ask that to me in a Telegram channel. Right. Or you can join, or you can also ask in the comment section. Okay? Amazing. Now, guys, the third problem. The third problem is actually splitting items. This is again a very basic greedy problem only. This is even simpler than the previous problem, I will say. Okay. What this problem said? This one simply says that there are some items actually present. Okay. And the thing is that Alice and Bob will one by one choose the items. First, Alice will take an item, then Bob will take an item. Okay. And finally, A will be the cost of items that Alice has taken, and B will be the cost of item that Bob has taken. And the total final score of the game will be A minus B. Obviously, Bob is trying to minimize the score, and Alice will try to maximize the score. Maximize, minimize simply means that Alice wants to increase the value of A, and Bob will wants to increase the value of B. That's it. ठीक है कि बॉब सोचेगा हमें ज्यादा कॉस्ट का आइटम मिल जाए, एलाइस सोचेगा हमें ज्यादा कॉस्ट का आइटम मिल जाए. तो बॉब विल थिंक दैट he wants more cost of items, Alice wants more cost of items. But because Alice will play first, Alice will start first, Alice will definitely pick the item with the highest value. So for example, items ऐसे दिए हुए हैं. Let's take some random value 5 1 8 7 6 9 2 3. Okay, so what we will do, we'll sort these items. It will become 9 8 7 6 5 3 2 1. Okay, items are sorted. Then what will happen? First item Alice will get, then Bob will get, then Alice, then Bob, then Alice, then Bob, then Alice, then Bob. Okay, and then maybe अगर odd number तो फिर एक और Alice. Okay. अब the problem is in this way Bob will get less number of item, right? Because Bob know first item always Alice will take, and that will be the maximum item. But what Bob can do, Bob can actually increase the cost of some of the item. Bob cannot decrease, no. Bob can only increase the cost of some item which is also less than equal to k. तो मान लो k आपका है 5, means Bob can increase the cost of only of items up to 5 only. तो Bob क्या करेगा? Bob will increase the cost of items which Bob will take, ना, which Bob wants to take. तो Bob को पता है कि वो 9 को नहीं बढ़ाएगा. Bob will not increase 9. Why? Because 9 already Alice will take. So even it will make this to 10, Alice will take it because it is the maximum. Second maximum, Bob will make this to 9. And also Bob will not make it 10, because if Bob will make it 10, then Alice will take it. So Bob will make it up to that level such that it is equal to the Alice value. It is not exceeding Alice value. Because if it will exceed the Alice value, Alice will take it. So Bob क्या करेगा? Bob यहाँ पे +1 करेगा to make it 9. Bob will do +1 here also to make it 7. Let's say इसे 3 है, 4 है. Then Bob will make +2 here to make it 5. It cannot make it more than that. Now Bob can also do a +1 here to make it equal to 2. But it cannot do. because he has to only make 4 increments which are already done, +1 +1 +2. And this is what the logic is, guys. That is the only logic. Okay. So if you will see, what we are doing here is we are simply first of all taking the values. Okay, then we are sorting in the decreasing order. I have simply used the sort and then reversed it. Okay, sort in decreasing order. And now for every pair I am checking. So for every I and I plus 1 I am checking. That is why I am jumping 2 times. So basically first I will check for this pair, then this pair, then this pair, then this pair, and so on. So for every pair, I will first of all see the difference. What is the difference of the value? मतलब Bob की value कितना कम है? How much the value of Bob is less than the value of Li? So basically Vi minus Vi plus 1. Just like here 9 minus 8. So let's say that value is 1 less, 1 point less. And Bob has k points. So if k is greater than or equal to that difference, so what Bob will do? Bob will reduce the difference and it will move forward. Because मान लो यहाँ पे 9 और 8 था, तो क्या करेगा Bob? वो उसको भी 9 कर देगा. तो a minus b का score 0 रहेगा. There's no need to add anything in the score because both are having the same value now. So when we will differentiate, score will be 0. तो हम लोग सिर्फ इसका difference store कर रहे हैं, right? I'm just storing the difference in the answer. I'm not scoring A separate and B separate. I'm just storing the difference, right? But the thing is, there can be a case come when the value of k is less and difference is more. Let me give you an example. For example, यहाँ पर हमारी k की value सिर्फ 3 होती है and 2k are already gone. So when 2k are gone, here you need 2 more k to make it 5. So I will not do it 2 more k. Na. Whatever k is present, I will take that much. So I will just make plus 1 because only plus 1 is present, right? So whatever is the difference, we don't care. जितना होगा उतना minus कर देंगे. And if still some difference is remaining, that we have to actually add in the answer. And then my k will become 0. And at the last also, guys, if number of elements are odd, let's say यहाँ पे एक last में एक 1 और होता, तो वो 1 तो फिर Bob doesn't have anything after it. So that one will always be added to the LIs and that will also come in the score. That will also will have here. जो भी last value होगी. And then finally we'll print the score, right? So finally you have to print the minimum possible score. So the thing is that Bob will try to increase the value of the second value of the pair if you will take pair, every pair. And also it will make that value up to the value of LIs only, not more than that. LIs की value तक ही ले जाएगा. ठीक है? So this is what we are actually doing. Okay, here. I hope that you have got understanding of this particular problem. But still, if you didn't got, no worries. You can just ask that to me in the comment section, or you can join Telegram. Okay, amazing, amazing. So this is the third problem, guys. So now let's discuss the fourth problem, a very interesting one. Okay, this problem actually I thought of that it is of a graph, but yeah, it's not a graph problem actually. It's just a problem, of basic greedy. Okay, the problem is that we are having n cities. Okay, and those n cities are located on a straight line. Okay, and the cities are also numbered from 1 to n. So there are n cities, and n cities are located on a straight line and numbered from 1 to n. Amazing. So I will actually tell you how it is working. Okay, so I will take an example actually, and through the example I will tell you. So because this is actually a little complex thing, so I will tell you how to do. Okay, so for example, this is 1, this is second city, third, fourth, fifth, sixth, seventh, eighth, and ninth. Okay, so let's say we are considering for 9 cities. Okay, amazing, great. Now see, portals are used to move between cities. So there are some portals which can be used to move between cities. Okay, and portals all of basically 4 colors: blue, then green, then red, and then yellow. Okay, so these 4 colors of portals are there: blue, green, red, yellow. Okay, amazing, amazing. Now what they are saying? Now they're saying that every city has basically 2 different colors of portal. So each city has just 2 colors of portal, not more than that. तो हर सिटी के पास 2 ही कलर के पोर्टल है, any of 2, right? We can allot them. So they are giving us for each city which portal they have. which two color portal they have. And also when they're giving the color portal, they're giving like that, BG. They will not say GB. They are saying BG, BR, BY. This is very important thing. The ordering of colors. So they are basically first giving that character which is having the less ASCII value, right? तो बेसिकली अगर आप ये चार कलर देखो तो इसके बेसिकली only these six combinations are there. These six combinations are there of these colors. If you will see, which the cities can have. These are the combinations. Okay, which is BG, BR, BY, GR, GY, RY. Okay, and we will only tell it in this way only for storing also. Why? We will not say YR. We will take this convention only that the first character is having the less ASCII value. Why? I will tell you later. Okay, amazing. बोल कह रहे हैं कि you can only move from a city I to city J if they have some same color of portal. For example, this city 3 has color BG, for example, and the city 7 has color BY. So you can move between them. Why? Because they have a common word called B. तो क्योंकि उनके पास कॉमन वर्ड है वो कर सकते हैं ट्रेवल. बट लेट्स से लेट मी गिव यू सम मोर थिंग्स. लेट्स से दिस इज आर वाई, दिस इज बी आर, दिस इज जी वाई, दिस इज जी आर, दिस इज आर वाई, दिस इज जी आर, दिस इज बी वाई. लेट्स से ये आपका कॉम्बिनेशन, राइट? तो फॉर एग्जाम्पल अगर ये जी वाला है ना, तो फ्रॉम दिस जी वाई कहां कहां तक होगी रोड. सो यू कैन सी यू कैन मूव बिटवीन टू सिटीज ओनली इफ they have portals of same color. Means from this gy you can move to ry because y is common. You can move to bg because g is common. You can even move to ry because y is common. You can move to gr, g is common. Again gr, by also because y is common. This y also because y is common, right? But you cannot go to br because nothing is common. Means you can directly not go there. Indirectly you can go there. Indirectly you can go there. How indirectly? So you can first go to, let's say, by and then to br, because you can go to by, y is common, and then you can go to br because bb is common. And basically your final distance will be the difference of the values. Let's say अगर आप यहाँ से यहाँ जाओगे, then your यहाँ से यहाँ, then your cost will be 7, 8 minus 1, and then here your cost will be 1, total cost will be 8. So basically between any two city, you have to tell the minimum possible cost. The minimum cost between any two city x and y. That is what you have to tell. Right. Just 1 minute. Okay. So this is what they are saying. But yeah. What we do have to do here, like what should we do, कैसे करना चाहिए इस प्रॉब्लम को. तो what they are saying, they are giving us some q independent queries. They are giving us some q independent queries. ठीक है. And for every query we have to find the minimum cost to move from city x to city y. हमें minimum cost find करना है from city x to city y. कैसे करेंगे? अब देखो guys, whichever city is directly connected, then simply we can just return the difference between their location. अगर मान लो ये BG वाली city है, it is directly connected to GR because they have common character. They have common what we are saying there, portal. They have common portal. So whenever two city have common portal, then obviously we can go directly to it. But in some cases the direct is not possible. Let me tell you that case. So एक मैं वाला केस लेता हूँ यहाँ से, लाइक कोई बेटर केस. मैंने थोड़ा गलत यहाँ पे बना दिया टेस्ट केसेस. वेट, ठीक है, अब देखो, for example, you have to go from BG to GR. You can go directly because G and G is common, right? Let's say you have to go from GY to BY. You can go directly because going directly is the best way. किसी के थ्रू जाओगे एक्स्ट्रा ही कॉस्ट लेगी इन मोस्ट ऑफ द केस, राइट? सो गोइंग डायरेक्टली इज द बेस्ट वे. जस्ट सिंपली रिटर्न द डिफरेंस बिटवीन द लोकेशन, बिकॉज उससे कम तो हो ही नहीं सकता है. इट इज नॉट पॉसिबल टू गेट अ कॉस्ट लेस देन द डिफरेंस बिटवीन द लोकेशन. But in some cases you cannot go directly. What is that case? For example, from this BG you have to go to RY. Means from city 3 you have to go to city 6. How you can go to from 3 to 6? How you can go? Because nothing is common. It is B and G, it is R and Y. There is no common thing. Now, what can we do here? So we must have to use something else. We can either go from BG to GR because G and G are common, and then from GR to this RY because R and R are common. In this case, this will cost 1, this will cost 4, final cost 5. And there can be multiple other ways, not just this. There can be multiple other ways also. So to basically find the minimum possible way to do this. अब ये कैसे करेंगे हम? देखो guys, how I have actually solved it. Let me explain you. So it's actually a complex solution. So I have to take it side by side. You can see it's a very long solution I've written. Maybe there is a better way also. तो पहले तो हम बहुत basic लेते हैं. What I did, I first of all took the number of cities and the number of queries. Okay, amazing. Then in this vector I'm storing all the cities. Okay, you can see I've taken the input of vector. Amazing. Now these are three things I will tell you what I am using it, why I am using these two maps. But this is the colors that I have, all that 6 combination of color I have taken in a vector, right? Up देखो, this what is this? I will tell you later. We are using it for something. I will tell you later. Okay, amazing. Now what I am doing is that for this all the query, I am taking the value of x and y, and you will see they are giving x and y as one base indexing, but we are taking 0 base indexing, so I am decreasing the value of them, right? And also I am considering that x should be less than y. Okay, the city x should be less than y, so if x is greater than y, I am swapping it, right? Now that particular x city, I am taking the petal or the portals at that x city and at that y city. अब देखो, if the portals of the x city and the y city, if they have any common character, as I told, अगर कोई भी common character है, if a0 is equal to b0, a1 is equal to b0, a0 is equal to b1, or a1 is equal to b1. So for example, in these both, r is same. Okay, in these two, r is same. Okay, then in this two, g is same. So any character is same. If any of the character is same, then I will return x minus y. X minus y means whatever is the difference between their location in the city, in the whole number line, I will say. Simple. Problem is when any of the two characters are not same. Means, as I said you, bg, this is x and this is y. In this case, what it will do? So for that, I have this whole logic. Now let me first explain you what is this. So this is basically actually used for finding and implementing a logic. अब ये है क्या? हम क्या कर रहे हैं? For every city, I am finding that for every city, before that city, which is the closest city having a particular portal. For example, मैंने क्या किया? इसको भी हटा देते हैं. What I did, I've taken a left map and I'm taking a right map. And this map are actually of long comma string. So this map will take two things. First, it will store the index and it will store the portal that particular city has. For example, आप देखो कि इस GY सिटी के पहले एंड फॉर एवरी कलर, हम हर कलर के लिए, तो बेसिकली हम क्या कर रहे हैं, फॉर एवरी सिटी, हम हर सिटी के पहले इस पर्टिकुलर कलर की क्या कोई सिटी है जिसका ये पर्टिकुलर पोर्टल है? अगर है तो उसके इंडेक्स डाल दो, अगर नहीं है तो माइनस में डाल दो. फॉर एग्जाम्पल इफ यू विल सी, आई विल राइट ऑल द पोर्टल्स हियर. कितने पोर्टल है? सो बीजी, बी आर, बी वाई, जी आर, जी वाई, आर वाई. फॉर नाउ रिमूव दिस, राइट? Okay, so for example, before this BG, is there any portal of before this GY, मतलब this current portal, Is there any portal of BG? No. -1. BR? No. BY? No. GR? No. GY? Yes. GY वो खुद है. So closest to this GY, before it, GY itself is there, so this is 1. Else -1. So you can see, I'm also storing for every portal its index in the map which is present before it or that also, right? Up same for GR. So for GR or for the second index, is there any portal before it having BG? No. Having BR? No. Having BY? No. Having GR? Yes. GY ये खुद है. क्या इंडेक्स है? 2. इंडेक्स स्टोर कर रहे हैं, राइट? Then is there any portal before it having GY? Yes, it is present. At what index? First index. Because in the map, we must have stored GY equal to 1. And now GR equal to 2. And RY is not there. Similarly for BG, BG is present at 3. Okay. BR no. BY no. GR at 2. GY at 1 and RY at -1. Not present. Similarly here, 3, -1, -1, 2, 1 and 4. So this is how for every particular city, before that city, on the left of it, for every particular portal, set of portal, which particular city is present closest to it, उसके इंडेक्स स्टोर कर लिया. एंड सेम फॉर राइट, कि राइट में कौन सी है. फॉर एग्जाम्पल इसके लिए ऑन राइट देयर इज नथिंग, only BR is there at 9, otherwise there is no portal. For this, BG is not present, BR is present at 9, BY it is self and else. तो अब देखो लेफ्ट के लिए we are going from the start and for right we are going from back and we are storing this thing. अब why we are storing this thing? Let me tell you that. For example, for every particular city we know कि before it, if there is any city having a particular notation, after it is there any city having a particular location and the closest city, not any, closest, कि भाई एक सिटी के लेफ्ट में सबसे क्लोजेस्ट सिटी कौन सी है एक पोर्टल की, लेट्स से GY की या GR की, या है भी कि नहीं, अगर माइनस में मतलब नहीं है, और उसके बाद कौन सी क्लोजेस्ट है, ये निकालना है, राइट? अब इसका हम यूज कैसे कर रहे हैं, लेट मी एक्सप्लेन यू दैट how we are actually using it. So guys, for using it, what I'm doing is that I'm taking this all. Let's say this is my X and this is my Y. So these are not equal. Up see guys, if this BG and RY, they don't have any common thing, that means I need one more city. Through them, I will go here. For example, I have to start from BG. I can maybe first go to this GY because G is common, and then from GY to RY because this Y is common. So basically, I will take all the other combinations of city which contains either of both BG और RY. कैसे? तो देखो, अगर हम BG से स्टार्ट कर रहे हैं तो I can go to BY, I can go to BR, or I can go to GR और GY. तो अगर हम इन चारों में से किसी भी एक सिटी में चले गए ना इससे, तो हम फिर यहाँ इसमें भी जा सकते हैं. If you will go to GR, then also I can go to here. If even I will go to GY, then also I can go to here. Or if I will go to so GR हो गया, GY हो गया. If I can even go to some BR here, then also I can go to here. Or if I can go to BY, then also I can go to here. So if any of these four combination I can go. Four combination basically are those combinations which are not equal to this BG and RY. तो इस BG RY को हटा के, if there is any other portal where I can go from this X and then to Y, that means I can go, right? अब वो कौन सा पोर्टल होगा? That will be obviously the portal which is close to this BG or which is close to this BRY. It should be either too close to BG on the left or on the right, that doesn't matter, or either close to RY. And that is what I'm doing. So first of all, what I'm doing guys, that for this particular ये मैं थोड़ा complex है guys, this can be actually done in a better way. I did it in a very complex manner. So yeah, I will actually explain you. If you want, I can actually code it again in a better way. This I did actually very in a wrong manner. Yeah, I think I should actually code it again and submit it again, because I actually did this in a very complex manner. Let me open the Codesef ID to code this. Okay. So you will see till here it should be clear to everyone, right? Till here it should be clear to everyone कि how we are taking this and how we are storing left and right. So for every city उसके लेफ्ट में कौन सी सिटी है, for that particular कलर पैलेट जो सबसे पास में है उसके इंडेक्स स्टोर होगा, सेम फॉर राइट, राइट. अब यहां तक भी क्लियर है कि इफ देयर इज एनी कॉमन कैरेक्टर इन द बोथ द सिटीज, आंसर विल जस्ट डिफरेंस ऑफ देयर डिस्टेंस. आफ्टर व्हाट आई विल डू if it is not there, for example, as I told you, wait, yeah, for example, yeah, for example, if this is bg and this is ry, so if this is bg and ry, so I can go to, I have to connect through any other city, and that city can be any other color palette apart from bg and ry. तो bg और ry के अलावा कोई भी और कलर पैलेट होगा ना चलेगा, right? So if these are these 6 color palette apart from bg and ry, to any other color palette I can go, and then again I can come to ry. ठीक है. So what I will do in this checks, I will first go through all the color palettes, auto ch colors which we have stored here, right? So first I will go to all the color palettes, right? And if that color palette is not equal to a, and if it is not equal to b, because it should be anything else from it, okay, it should not be bg, it should not be ry, it should be anything else, so that we can connect to both x and y. Then I will insert it inside this checks, because उन सारे कलर पैलेट के हम लोग चेक करेंगे. ओके, वी विल चेक, अमेजिंग अमेजिंग, वी विल चेक फॉर दैट पर्टिकुलर कलर पैलेट. ओके, अब वो चेक कहाँ कहाँ हो सकता है. लेट्स से दैट वी आर चेकिंग फॉर द कलर पैलेट gy, means from this x I will go to gy, and same for right also. So which gy we should take? We should take gy which should be close to x and y. So first I will take the closest gy, which is close to x on the left of. तो आप देखो कि x के लेफ्ट में सबसे क्लोजेस्ट gy कौन सा है, which is the closest gy on the left of x, that I will get from this left x ch, means left x3 and gy. That for the third index उसके लेफ्ट में सबसे क्लोजेस्ट gy कौन सा है, and it will give you the value 1, कि फर्स्ट इंडेक्स पे सबसे क्लोजेस्ट gy है. तो मतलब जो x है 3, उसका डिस्टेंस 1 से प्लस इसका डिस्टेंस 1 से, ये आपका आंसर हो जाएगा. वाई? बिकॉज फर्स्ट यू विल गो फ्रॉम हेयर टू हेयर with the cost of 2, then from here to here with a cost of 5, and total 7. But this is just for the left of x. Then I will check for the right of x also, कि भाई अगर क्या x के राइट में कोई gy है, नहीं है, फिर y के लेफ्ट में देखो, फिर y के राइट में देखो. तो for all the 4 things I will check कि if that gy is present left of x or right of x, left of y or right of y, and not just gy, all the 4 things, gy, gr, br and by, for all 4 which are in this checks, okay, which are present in this checks. So उन सबके लिए हम चेक करेंगे, right? So I have taken in this check, and I have taken an answer which is currently int max, because I have to check for minimum of all. अब उसमें भी क्या करेंगे हम लोग, ये I have done very, this is a repetitive code which should not be there. So I have to check for distance now. So I will take all the vertices which is possible. So I will say क्या कर रहा हूँ, possible indexes, right? तो क्या करेंगे कि फर्स्ट आई विल सी कि इफ लेफ्ट ऑफ x एंड ch, मीन्स आगे जो ch है इसके अंदर रखेंगे हम लोग उसको, सॉरी, विल कीप इट इनसाइड दिस, कि फॉर दिस पर्टिकुलर ch, इफ ऑन द लेफ्ट ऑफ x, अगर x सिटी के लेफ्ट में कोई ch है, मतलब इफ इट इज नॉट इक्वल टू -1, बिकॉज अगर नहीं होगी देन इट विल बी -1. बट इफ देयर इज सम ch, देयर इज सम सिटी विद दिस ch क्या क्या होगा, जो भी पॉसिबल कॉम्बिनेशन है, gr, gy, br, by. If there is any ch city present on the left of x, दैट मीन्स वो एक पॉसिबल इंडेक्स हो सकती है चेक करने के लिए. तो आई विल पुश बैक it inside my what push back whatever dot index was, and not just for the left of x, we'll check for the right of x also if that ch is present right of x, and not just x, we'll also check for y. We'll also check for right of y and left of, and for all these possible indexes which is possible to go through, I will find the minimum distance. So क्या करेंगे, I will go through all the possible indexes, and distance क्या होगी, distance will be first find the absolute difference from x of that index, and then find the absolute distance from y of that index, and then my answer will be the minimum of all. And if at the last the answer is just int max, that means answer is not possible. I will print -1. This will print -1. And hence answer will be the answer, whatever is the case, right? So this is how we are doing it. I will actually submit because it's a new code I have written. So I will actually try to submit it. Okay, it's the problem number D actually. Okay. And actually for this I also made many wrong submissions, if you will see. Yeah, so I will see it should be submitted, but yeah. So guys, this is how we are actually solving this particular problem. Okay, I actually submitted a better code for you guys so that you can have a better clarity. That logic actually I made very long, which was even not required. Okay. So yeah, this is something that we did, and this is how we are actually doing the things, right? So if there's any common character, we can directly go. If there's no common character, then we have to find a city through which I will go, and whichever city is closest, that only I will take, right? So that is what we are doing here. Amazing, amazing. Okay, let me see if it is submitted. Okay, it is running on test case 1. What happened? Okay, is it failing? Yeah, because I just submitted without even testing the first test case. Okay, it is running on second. That means first test case has been passed. It should pass. Actually, Codeforces are slower. So that's the thing. But it should actually pass. I didn't made much changes, I think. Yeah, I'm taking all the checks which are not equal to b. तो पहले check होना चाहिए, I think so. ऐसा ब्रैकेट लगाना चाहिए क्या? I don't think so. Then yeah, second pass हो जाएगा तो I हाँ okay. Now I feel little confident. Yeah. So cool guys, this is how we are doing it. Okay. This is how we are actually doing it. Okay, how we are solving this particular problem, which is fourth one. Okay, amazing. Cool guys, so you can see that for this D we have got the accepted solution for it, right? And the new one that we have written now, which is better than my previous submission, right? Now guys, finally the fifth problem, which is the Nim problem. So guys, this is the problem I was not actually able to do during the contest. Actually, I have even not given the whole contest. I just gave the contest till first 1 hour, and the 1 hour I was able to solve the four problems because after that I was having a class, right? So yeah, but actually this is a very good problem of game theory, which is based on the Nim problem. So it is saying not a Nim problem, but this problem actually is based on the concept called Nim. Yes. So if in games theory in Combinator, actually guys, there's a concept called Nim. I will actually share the article of that with you. I've already opened. This is the first article you will see of the Nim problem, where you will get that, and secondly you can also get this Nim problem in GFG also. There is a, yeah, this is the proper article of game theory of Nim problem. What happens in this Nim problem? This problem is exactly same. So see what are is given in this particular problem. In this problem, it is given that there are some piles of stone, like this is there is every pile of the stone. There are some there are some piles, and in every pile there are some stones present, right? And what will happen? In first Alice will go, then Bob will go, and in every turn the person can get any number of cones from a pile. This is a basic problem. For now, just don't take this condition. The basic problem is that first Alice will go, then Bob will go, they will go alternative, and in every turn, Alice or Bob can get whatever number of stones they want from the pile they will get, right? I'm saying coins, stones, right? And then whichever cannot make a move will lose, right? This is what is giving. And that is what the Nim problem is also, guys. In Nim problem also what happens, that there are some stones or coins present, okay, in different piles. First Alice will start, then Bob will start, and they will take whatever number of coins they want. And at last, whoever takes the last coin or the last stone, whichever person will take, they will win, because the next person will not be able to get the coin. Okay, so it is actually a proper game theory problem, you can say, which contains the proper proof, a mathematical proof. So I will not actually go much into the proof of it, but the eventually the algorithm says that if there are some piles and each pile contains some coins which is given to us in the form of an array, and if the XOR value of this array is actually 0, that means the second person will win. The person who will start second will win. Means in our case, Bob will win. So if the XOR value of an array is 0, that means Bob will win. And if it is not 0, that means Alice will win. But you will say, Abhinav, in our case, it is not the basic Nim problem. Here we have added a condition that you cannot always put any number of stones. See, if we can take any number of stone, then it's a simple problem that you will just find the XOR of the whole array according to this algorithm. And then if XOR is 0, answer is Bob, else Alice. But here they are saying that you can only take that much number of coins if y is, and if x and y common divisor, GCD, greatest common divisor, is equal to 1. If it is equal to 1, then only you can take it, right? That is what they are saying. So here also there is a, again it's a Nim problem only, but it's a little bit, of a change that we need to do. So first of all, I will say you will not understand this unless and until you are not good with this Nim problem. So if you want to understand the later logic, I will recommend you to first go to this Nim algorithm. Okay, how it actually works. First go to this Nim algorithm, and once this Nim algorithm will get clear now, you will also get clear to this approach, because even you see this is also a problem which is difficult for me. Even I was knowing the Nim algorithm, but yeah, doing this change was little bit difficult. But I actually tried and absorbed and got the logic at what it is happening. So basically, guys, what is happening? Even if we are having this condition, okay, then also for every particular pile we have some number of coins that can be taken as a normal Nim problem. So basically this modified Nim problem will try to convert to a normal Nim problem. For that, what we will do, for every number we will find its equivalent stones or its equivalent coin in the Nim problem. How we can find? For example, I will say for 1 it is just 1 in the Nim problem. For 2, it will be taken as the 0 in the Nim problem. For 3, it will be taken as 2. 4 will be taken as 0. So basically, all the multiples of 2 will be taken as 0. All the multiples of 3 will be taken as 2. And for all the prime numbers, will increase the count. So you can say previously count was 2, it will become 3. For 6, it will be 0 only because it's a multiple of 2. For 7, it will become 4, increased by 1. For 8, it will be 0, multiple of 2. For 9, it will be a multiple of 3, so it will be again 2. For 10, it will be 0. 11, it will be 5, one more than the last prime. So you can see, using this pre-compute DP, what I'm counting it, I'm counting this DP array. This DP array is actually storing the equivalent number of stones or equivalent number of coins if it was a normal Nim problem. So basically what I'm doing, how we are doing it, I will tell you. First, what are we doing? What I'm doing is, we're starting from 0. For 1, it is 1, 0 is 0. And when I is 3, it's 2. When I is 2, it's 0. This is also, I will tell you why. And for every prime number which is currently -1, I'm going through all of its multiple and I'm making its value equal to that prime number. Right. For example, अगर 7 के लिए 4 है तो जितने भी 7 के मल्टीपल हैं उनके लिए 4 होगी. अगर 2 के लिए 0 जितने भी 2 के मल्टीपल उनके लिए 0 होगी. And for every prime number it will be increased. For example, 12 के लिए 0 होगी, फिर 13 के लिए फिर से 6 होगी, एक बढ़ गया. तो अब देखो TUT जो है ना, there we are counting the increase, right? अब हम ऐसा क्यों कर रहे हैं? Why it is 6 for 13? Why it is 5 for 11? Why it is 0 for 2? So basically guys, if you will see, let's say that there are 2, 4 and 6, right? तो होगा क्या, अगर 4 है तो लोगों की सिर्फ 3 और 1 ले सकते हैं, मतलब वो क्या करेगा, वो y 3 होगा और x आपका 4 है, तो y को 3 ले सकता है क्योंकि इनका जो जॉर है वो 1 आ जाएगा, फिर रिमेनिंग 1 होगा तो 1 ले सकता है, 1 हो जाएगा, राइट? तो व्हेनेवर इट विल बी इवन, आपके दो पॉसिबल स्टेप्स होंगे। अगर एल से एक स्टेप चलेगा, बॉब उसको जीरो कर लेगा, अगर एल से एक स्टेप चलेगा, बॉब उसको जीरो कर लेगा, बिकॉज बॉब चाहता है कि लास्ट में जीरो आपके हो जॉर की वैल्यू, राइट? तो इफ एलाइस विल प्ले अ टर्न, बॉब विल ऑलवेज प्ले अ टर्न जो उसको जीरो कर रहा है, अगर पूरे की जॉर की वैल्यू जीरो है, राइट? तो अगेन गाइज आई विल से, first I will recommend you to just go through this NIMS algorithm. Okay, if you understand this NIMS completely, then it will be very easy for you to go through this and get the modification of this, that how we are getting this equivalent. There's a concept of max also. Okay, that how the max of a number can be taken considered. It is actually very advanced. I was actually not even taking this problem in this video, but yeah, I thought to take it. By the way, guys, I saw that this code was actually leaked, and many people have shared this on, because I saw the last some submissions of this fifth problem. They all were repetitive submissions, all of them the same thing. So this last code is actually guys leaked. That is why it is having this much number of submissions, because this is actually a difficult problem. It should not have this much number of submissions, but because it was leaked by the cheaters, we got this much number of submissions here. But yeah, that is what it is. We can't do anything for it, right? Cool guys, so this is all the 5 problems we discussed. I hope that you have got to understand this particular video. Thank you.